The last topic in forecasting is called tracking signal. Tracking signal is used to monitor and control forecasts that are ongoing. So usually at some point in time you analyze the data, you consider various different models, select the approach that gives you the most accurate forecast, and typically you will automate that. You will put it in the system and the system will spit out. And this is especially for short-term forecasts, forecasting every day for next day or every week for the next week and so on. So it is in production, for instance. Okay, right? So it's spitting out forecast period after period after period. Now, how do you know whether what when you implemented it, what worked very well is continuing to give you accurate forecasts? So there must be a way of automatically monitoring the forecast errors, and if the forecast accuracy has deteriorated, there must be a signal that should be raised so you can go back and redo the analysis and make the necessary adjustments. So that's what tracking signals are for. So that's monitoring an ongoing situation where forecasts are automatically generated based on the model that you selected and that was giving reasonable and acceptable forecasts. So what do is you every time period when a new actual sales comes in, so you have the forecast and then the actual comes in, then you calculate in a running sum of forecast error and a running MAD, and then you do a ratio of these two, then that is called a tracking signal. So running sum of forecast error takes care of the bias, right? So it is not running sum of absolute error, running sum of forecast error, so positives and negatives. So it will go up and down, sometimes negative, sometimes positive. And then you divide by the MAD, so it keeps it in a kind of a unit-free measure, right? So if it has too many negative errors or too many positive errors, it will slowly drift back and forth. Okay, so like that. Okay, so you have control limits. So that's the acceptable range. As long as it is in this range, then you leave it alone. But if that tracking signal goes beyond the acceptable range, either on this side or on that side, then that is the time for intervention. Okay, so positive tracking signal indicate demand is greater than forecast. You're under forecasting. So negative means you're over forecasting, so the demand is less. So your good forecast is something where there is as much positive errors as negative errors. So that's a key. And the limits that you choose is a reasonable value, plus or minus 2, if you want to be really careful. Okay, because not all items are equal. Right? There are some items which are very critical, and you have to make sure that your forecasts are accurate. Then you set a very narrow range, plus or minus 1.5 or plus or minus 2. But if it is not such an important item, okay, then well you can have a more generous range of acceptable values. Okay, so let's look at how to compute this running sum of forecast error and the running MAD. So this MAD is different from the MADs that we calculated for the purpose of comparing different models or different parameter values. Okay, so here let's start. Okay, let's assume that we have period number 1. So you start with the forecast. Let's assume that you use some method and you have the forecast. Now at the end of t equal to 1, so this happens at the beginning of t equal to 1. At the end of t equal to 1, the actual sales comes in. Okay, it turns out to be that. So then you compute the error. So actual minus the forecast, right? So that absolute error. So running sum of forecast error, at this point there is only one error. So that's our running sum of forecast error. Okay. MAD is the sum of, MAD is the average of these absolute errors, right? Now I'm going to use a range that can be copied. So average of F7, right? I will anchor that like that, right? And then F7 itself. Well, let's do it this way. Then go back and put, so F7 is anchored, so F7 to F7. So that's our MAD. So now the tracking signal is RSFE divided by MAD. So that's the first one. Then comes along, now at this point in time, you're at the end of t equal to 1, right? Or beginning of t equal to 2, then you're going to develop a forecast for t equal to 2. Okay, let's assume that forecast is again 100, right? Now, at the end of t equal to 2, then the actual sales comes in, all right? So now, copy that. So that's our error now. Okay, so that's the absolute error. Now RSFE is running sum of forecast error, so the previous RSFE plus the current error. Okay. Now because we set up the average range as F7 anchored through F7, now if I copy this down, F7 will be anchored at F7. The second F7 will be F8, so you'll have two values. That will be the average of two values. See now F7 to F8. So that's our new MAD now. So that's why this MAD is different from the MAD that we used for comparing models. All right, so now that copy that, then you get -2. Now period 3 comes along. Okay, beginning of period 3. You have a forecast for period 3, again 100. And end of period 3, the actual comes along. Okay. So now you can copy this whole thing down. So now we have 0 for time tracking signal. Now next period, beginning of 4, forecast is 110 now, and then end of 4 you have the actual, then the tracking signal. Yeah. And then period 5, okay, first the forecast, and then end of 5 get the actual. All right, so now let's now one more. We'll do one more. Okay, first forecast, then actual. All right. So if your tolerance range is ±2, then this would mean you need to intervene and make adjustments. If your tolerance range is ±3, then this will be okay. So this is how tracking signal works.